Okay, this one reads, the following box plots show the relationship between the number of cylinders a car engine has and the car's fuel economy. And so we have box plots here. So we have a cylinder, you've got 4 cylinders. It ranges from around 20 to about 37 or 38, something like that. And so we have all 4 of these. This one's got an outlier. So state the null and alternative hypotheses. So again, the null is that they're equal, and then the alternative is that they're not equal. So C is the only one that works out. Okay, do the conditions for ANOVA seem to be met here? So let's kind of review. So are each of these independent of each other? We're just assuming we can assume independence on these, I believe. And we got to look within the group and across the groups. So within each group, we're not given any indication that they picked only certain brand of cars. Right, so we're assuming that they're going and getting a nice random sample from a bunch of different automakers. We have a randomization condition, so it never says they're randomly selected, but we're just assuming that they're randomly selected. We often have to assume independence and randomization unless something tells us that there could be dependence or that there was no random selection. And the last condition is the only one that we can really check. We can look at our graph here. Let me blow it up a little bit. And the variances need to be the same or very close to the same in order for us to use ANOVA. So just looking at the box plot, I'm comparing just sort of the width of these, and they all look pretty good except for 5 cylinders. It's all squished in here. I'm curious what it looks like. I'm not sure what N is for each of these. That'd have been nice to know, but there's very, very little variability with 5-cylinder cars. Maybe there aren't a lot of 5-cylinder cars. I've never really heard of a 5-cylinder car, to be honest with you. Not into cars too much, but usually 4, 6, or 8. So we can't use ANOVA on this. This definitely violates the equal variances condition. So let's see what our choices here. So C. Equal variances condition is not satisfied.